Hi guys, in this video we will be looking at MIP 1501 January February 2024. Right, so as we are revising our October November 2024, it is essential for us to go through this question paper as a form of practice. If you are new to this channel, what are you waiting for? You kindly subscribe once. Don't forget to like and comment. Well, we'll start with question 1. They said, what is the name of the numeration system that is currently used all over the world? Well, the name of numeric system that is currently used all over the world is what we call a Hindu-Arabic numeral system. It's very essential to go to your study guide and check. Yes, that's why it's very important to prepare, right? Let's put that into practice. Yes, at 1.1, we said it's what? It's Hindu. It's gonna be Hindu Arabic numeral system. Numeral system. Okay. It's Hindu Arabic numeral system. Then let's go to 1.2. Right? At 1.2, they said give any 4 characteristics of a numeric system mentioned in 1.1. Well, any 4 will be that these characteristics include a base 10 system, which is called a decimal system, right? Then 2, we can say it uses 10 digits, maybe from 0 to 9. And the third one will be a place value system. Well, a place value system, when it comes to a place value system, is that it determines the position of a digit, right? So that's how you can those are the characteristics of 1.2, yes, of a numeric system, right? That's how it goes with the numeric system. So let's put that into practice. Let me write it so that you're able to I'll give you 3, then the 4th one, it's a duty to find it, right? Okay. All right. Just as I've said, it uses a base characteristics that it uses a base 10 system, base 10 system. It uses a base 10 system, or what we call a decimal system, right? A decimal system. Okay. The second one, I said that it uses 10 digit, meaning 0, 1, 2. Those are the example. 3, 4, 5, 6, 7, 8, 9. It uses a 10 digit system. It uses a 10 digit, right, system. So what we call the third one, it's that it uses a place value. It uses a place value system. It uses a place value system. Then which determines position of a digit. So guess the fourth the fourth one, but for the fourth one, I'll leave it to you so that you can find so that you tell me what's the fourth one, right? So you can feel free to tell me on the comment section. That would be highly appreciated. The fourth one, let me leave it for you. So then we'll go to 1.3. Well, for 1.3, they said write down the 5 Greek alphabet letters and their names. Well, the first one will be alpha. I don't know. Yeah, it's like this, the symbol. Alpha will be alpha. And the second one will be beta. Beta will be beta, their name, right? The third one, that R, which is a gamma. We call it a gamma. That's gamma. Then the fourth one is delta. They love this in physics as well in maths. Delta, which means change, right? Delta. Then these are the Greek symbols. The fourth one, you can see this in radios. In physics, we call it, in physics as well, we have this. Let me write it well. It's called an omega. Omega. This is an omega. It's an omega, right? We call it an omega. So 1, 2, 3, 4, 5 years. So in their names, right? Then you get that beautiful 10 marks. 10 marks for symbols in their names, meaning it's 2 each. 2 times 5, which is 10, right? So we are going at we're looking at now 1.4. At 1.4, they said explain mixed fraction and improper fraction on grade 4 learners by giving 2 examples. Well, for me to explain adding mixed fraction and improper fraction, guys, to grade 4 learners, I can use examples. Let me show you using examples, right? Let's to explain adding mixed fraction and what you call improper fraction to grade 4 learners, I will explain by giving 2 examples and solutions. For instance, we will first convert this mixed fraction. Remember, we're given 1.5 plus 2 1 all over 3. So first thing, you'll convert this mixed fraction to improper fraction. You're right. First thing, convert mixed fraction to improper fraction. So meaning that I will say 1 times 2, which is 2, and add by 1, that's 3. So in other words, I'm going to be having 3 divided by 2. You keep the denominator the same. Then similarly, 2 times 3, that will be 6 plus 1, that will be 7. Keep the denominator the same, which is 7 all over 3. Then the second step, I'll find the common denominator, or what we call the lowest common denominator, which is an LCD. So I can see that 2 times 3 can give us 6, right? Meaning that the LCD will be 6. So to make life easy, what am I going to do? I am going to say 3 all over 2. For me to make it to 6, and I'll multiply by 3, the numerator and the denominator. Similarly, for me to make it to 6, I'll multiply the numerator by the denominator. So what am I having? I am having what here? I'm having 3 times 3, which is 9, and 2 times 3, which is 6. I'm also having 7 times 2, which is 14, and 3 times 2, which is 6. So from here, I will need to add this. What is 9 plus 14? 9 plus 14 will give us 23 divided by 6, right? So we'll also have to leave our solution as a mixed fraction, guys. No? So listen to me very carefully. Remember, you can take that 23 divided by 6, no? And if you're using KGFX and press equals to, then you can say shift. Then there's a button written is SD. Automatically, it will change this to 3 and 5 all over 6. Or you can do it mentally. So in this case, we are going to say 3, 5 divided by 6, which is 3 times 6 will give you 18, plus 5 will give you 23, then 6 remain the same, right? So that's how I would have explained to the learners when it comes to a mixed fraction. So what about when it comes to the improper fraction? Let's talk about the improper. When it comes to the improper fraction, remember, adding improper, guys, remember we have, for example, example 2, let's say I'm having 7 all over 4 plus 5 all over 4. These are improper fractions. What we can see from this improper fraction is that the denominators are the same, right? The denominators are the same. What do? You add the numerator. In other words, 7 plus 5 will be 12 divided by 4. Then how many times does 4 goes into 12? It goes 3 times. So we get marks on this, right? We get marks on this. I hope, guys, it does make sense. No, I hope it does make sense on that, right? So we can go to question 2 now. Well, at question 2, they said express 73,063 and 629 in weights. Well, that is, first thing, you can write it now. That's 73,063 and 600 and 629 thousands. That's how you will have written that. Let us put it in weights. Then we'll put it as well as in place value and in terms of power of 10, right? Okay. Let's put that into practice. So remember, we're at 2.1. We have to put 63,629 in weights. That will be 73,000 and 63 and 600 and 600 and 600 and 63, I mean. Okay, 63 and 600 and 29,000. Then that's it in weights, right? So in place value, guys, in terms of place value, let me put this 7 will be in 10,000s. 7 will be in 10,000s. Then 3 will be in 1,000. 0 will be in hundreds. Then 6 in tens. Then 6 in tens. Right, we said that 0 will be in hundreds and 6 in tens. Then 3, the other 3, which is this 3, will be in units or ones. Then we have the other 629 under 629. This will be in tenths. Then 2 in hundreds. Then 9 in thousands. Is it thousands? Yes. Sorry for my spelling. Yeah, I'm sorry for my spelling. So they said in powers, in terms of powers, what do we do? That will be 7 times 10 to the power of 4. Plus 3. Yes, it will just depreciate in terms of force. Yes, you multiply by 10,000. The reason, you know, that the reason I multiply by 10 to the power of 4 is because 10 to the power of 4, guys, it's the same as thousands. The same as 10,000. Remember, just as we have said, that's why I put 10 times to the 10 to the power of 4, because it's in 10,000, and 10 to the power of 4, it's 10,000, right? Then the 3, remember 3, it's in hundreds. Then it's in thousand, so 3 will be in thousand, so it's gonna be 3 times 10 to the power of 3. Then plus 0 times 10 to the power of 2. Remember, the 0, it's in hundreds, and 10 to the power of 2, it's in hundreds. Plus Remember, now we go to 6, right? This 6, so 6 is in tens, so it will be 6 times 10 to the power of 1. 6 in tens, 3. Then we add by 3. 3 times 10 to the power of 0, because it's in tens. So 10 to the power of 0, it's tens. Then plus, okay, we said that 3 times 10 to the power of 0. Then we also have 6 times 10 to the power of -1. We are going backward now, but this is in tens. This is the same as, say, 6 times 10 to the power of 6 times 1 all over 10, right? Plus 2 times, it's in hundreds, 2's. This 2, it's in hundreds. So, but we are going backward. So that's why I'm using negative. Plus, what do we call 9? Because it's in thousands. So, but remember, it's the same as saying 9 times 1 all over 1,000, right? So we are going backward in other words here. That's why I am writing this in negative. So this is how in powers, in terms of power, in powers of 10. This is how you write it, guys, in powers of 10. You follow your place value, then it will guide you. Remember, using a base 10 system, right? Hope, guys, you did understand 2.1. We can go to 2.2 now. At 2.2, they said differentiate between real and non-real numbers, and give example. Well, real numbers, guys, include all numbers on a number line. No? It includes all numbers on a number line. I hope you're writing. It includes all numbers on a number line. That's real numbers, right? The examples will be 3 and -5. Another example, we could say 3, 75. Then what about non-real numbers? 2.2.2. Non-real numbers do not exist. For example, the square root of a negative number, which is equals to imaginary. That doesn't exist, guys, right? Let me put that into practice. For real numbers, just as I've explained, I hope you have listened well. We said it includes all numbers in a number line, e.g. that's 3. You can have -5, 3.65 as an examples. Then we have non-real numbers. They do not exist. They do not exist. E.g., square root of a negative number, square root of -1, will not exist. If you put that in your calculator, for example, so that you can confirm, you can see it says net error. So they do not exist, but they are equivalent to imaginary, right? When we go to the varsity standards, the varsity standard says that, right? So we will move to 2.3. Well, at 2.3, they said differentiate between rational and irrational. Give examples. Well, guys, when it comes to rational and irrational numbers, these rational numbers are numbers that can be expressed as fraction or ratio. Yeah? They can be expressed as fraction or ratio. I hope that you will note that. Then in terms of irrational numbers, I usually call them crazy number. But when it comes to irrational numbers, these numbers cannot be written as fraction. These are numbers that cannot be written as fraction. I hope you have differentiated between the two. I hope you have listened very well. Note that in the book. Remember I said rational numbers can be expressed as fraction or ratio. 2, irrational numbers cannot be written as fractions. So now I'm going to write the example so that you are able so that you comprehend what I'm saying, right? When it comes to rational, remember I said rational numbers can be expressed as fraction, e.g. 2 divided by 5, or we can express it in terms of decimals, 0.5. So non-real, for irrational, sorry for that. For irrational numbers, I'm talking about what? E.g., we are talking, and remember that for irrational numbers, these are non-repeating numbers, e.g. square root of 2 and pi. We have pi in our calculator, and pi is also part of irrational numbers. For 2.3, then let's go to 2.4 and 2.5. Discuss in detail any 5 facts, special facts to remember about the number 0. The number 0, they said we need to discuss any 5 special facts to remember about number 0. Well, the special facts about number 0 is that 0 is an identity element. You can add it by any number. It is that number. Maybe 2 plus 0, that it's still gonna be 2, right? So and we also, another special fact about 0 is that it's neither positive or negative. It's neither positive or negative. Then the third one, multiplying any number by 0 will be 0. Maybe if I say 2 times 0, that will be 0. 5 times 0, that will be 0. Fourth part is that a placeholder, which is a placeholder, e.g., for example, it can act as a placeholder, e.g., will be 102. 102. It's a placeholder, right? We can see 0 there at 102. I hope you're writing, guys. I hope you're writing that in your books. Then the fifth one, it's undefined. It's undefined. It's undefined, meaning when I say it's undefined, let me show you what I mean. For undefined, guys, it's the same as a number dividing 0. It's another special effect about 0. It's undefined. 5 divided by 0, it gives you a math error. So that tells you that 0 can be undefined. I hope you have written what I've said, guys. Then at 2.5, they said discuss why intermediate phase learners, discuss with intermediate phase grade 4 learners why the absolute values are necessary. Let us call that a homework for you. Since you're home, a personal work to do. I want you to tell me on the comment section why absolute values are necessary. That will be highly appreciated. It will be good to hear different views from this. At 2.5, let's answer it at the comment section and discuss it. Then that will be highly appreciated. We will go to our next video will be about question 3.